Good morning, grade 7s. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all really well today and looking forward to the lesson. A reminder of the email address on your screen, grade7@worksheetcloud.com. Please feel free to send me any questions, suggestions, perhaps there's a topic you'd like me to cover, and I'll be happy to do so moving forward. Today we are looking at algebra. And in particular, we're going to be looking at expressions and like terms. On either side of that theme, there's our warm-up, our mental arithmetic questions, and then our brain bender to finish off on. Let's have a look at our warm-up activity for today. So you know that you need to use your math skills to find the value of each symbol. Don't forget the question mark at the end. Take your time, there's no rush, check your work. Make sure you go over it and that it all makes sense. Write down your thoughts. It'll be a lot easier to understand. And let's see how you guys get on. Look at starting on the third line. I know that 25 multiplied by 1/5 is equal to 5. Now, how do I know that? Well, I know that 25 can be written as 25 over 1. And then I can multiply that by 1 over 5. And we know that when we multiply fractions, we multiply the numerator together. 25 times 1 is 25, and we multiply the denominator together. 1 times 5 is equal to 5. That means 25 divided by 5, and we know that is equal to 5. Okay, so let's put that answer in. That's equal to 5. Okay, so now I can just put 5 in where I need it to go. Right, let's have a look at the second line. So here we have 4 over a tiger is equal to 1/5. So we're looking for the equivalent fraction of 1/5 where the numerator is 4. So how did I get from 1 to 4? I would have multiplied by 4. So whatever I do to the numerator, I must do to the denominator. So 5 times 4 is 20. So the tiger is equal to 20. Clear some space. Okay, so now if I know that the tiger is equal to 20, then I need to look for the equivalent fraction of 5 over 20, where the denominator is 100. Okay, so how do I get from the tiger, which is 20, to 100? I multiply by 5, so that means I need to multiply the gorilla, which is 5. I need to also multiply that by 5, and therefore the bear is going to be 25. So at the top, I will have 25 over 100 equals 5 over 20. Okay, all that's left for me to do now is the last line. I know that the bear is 25. I know that the tiger is 20. And I know that the gorilla is 5. So 20 minus 20 is 5. And then 5 minus 5 is equal to 0. Okay, so well done if you remembered how to work those out. So we're just looking at multiplication of fractions and then also equivalent fractions. Replay it. Make sure you understand it. Let's go have a look at our mental arithmetic for today. Your mental arithmetic practice is on the screen. 9 questions. All previously taught principles, so just a good way for you to keep those principles fresh in your mind. I'm going to remind you again to set your work out logically, write it down neatly, check your work, make sure you write down all your thoughts, and yeah, let's see how you guys get on. Question 1 is 178,910 plus 158,762. Straightforward addition, 0 plus 2 is 2. 1 and 6 is 7, 9 and 7 is 16. We know the decimals must line up. 8 and 8 is 16, plus the 1 is 17. Carry it. 7 and 5 is 12, plus the 1 is 13. And then we have 337,672. Remember the checking strategy. We can take the answer and subtract any of the numbers in the question, and it should be left with whatever number you didn't use. So if we subtracted 158,762, then we should be left with 178,910. So let's have a look at what answer we get. 2 minus 2 is 0. They line up. 7 minus 6 is 1. So they line up. I can't do 6 minus 7, so I need to borrow. 16 minus 7 is 9. Okay, they line up. Decimals in the same place. I can't do 6 minus 8, so I must go 16 minus 8 is 8. And you can see the 8s are the same. I need to borrow again. So 12 minus 5 is 7. And you can see the 7s are the same. And then 2 minus 1 is 1. And you can see the 1s are the same. So therefore my original calculation must be correct. So happy days, I can move on. I don't ever have to look at that calculation again. I'm confident knowing that I've got it correct. And remember, these are checking strategies that we want to use in assessments. So make sure that you understand how they work. So subtraction next. And the first thing I'm going to do to 438,1 is just to add another 0 there. So we have the equal amount of numbers in both the top number and the bottom number. So it's just a bit visually easier to have a look at and understand. We know 0 minus 0 is 0. 1 minus 0 is 0. Decimals line up. Borrow as always when we need to. 17 minus 8 is 9. 12 minus 3 is 9, and then 7 minus 4 is 3. So we're looking at 399,00. So now we need to check, and remember to check, we just do the opposite, which is add. So 0 plus 0 is 0, that works out. 0 plus 1 is 1, that works out. 9 plus 8 is 17, that works out. 9 plus 3 is 12, that's good. And 3 and 4 is 7, so that works out. So I know my calculation must be correct. Okay, next we have a long multiplication question. And that question is 156 multiplied by 21. And I'm going to tell you straight away that all I'm going to do is 156 times 20. Okay? And then I'm going to add 156 times 1. Right, and 156 times 20, I can just say 156 times 2. Okay, and that's going to give me 312. But remember, I'm multiplying by 20, so I need to include that multiple of 10. And to that, I must just add 156. And then you should be able to get an answer of 3,276. But we should check that, okay? So let's check it using a different strategy. And there, as you know, there are quite a few strategies that you can use. Let's do long multiplication in the column method. One times 6 is 6, 1 times 5 is 5, and then 1. And then we need to include the 0 because we're multiplying by a multiple of 10. 2 times 6 is 12, carry the 1. 2 times 5 is 10, add the 1 is 11. And 2 times 1 is 2, add that is 3. So now we can have 6 plus 0, 6. 5 and 2, 7. 1 and 1 is 2. And 0 and 3 is 3. So happy days, we must be correct. Okay, I can move on. Next we have the division, a short division question. We're dividing by 2. So for this we can just use the standard short division method. Okay, 2 doesn't go into 1. So 2 goes into 19 9 times with 1 left over. Remember the decimals line up. 2 now goes into 10 5 times, nothing left over. 2 does not go into 2 does not go into 0. And then 2 goes into 4 twice. Remember that we should check this by saying 9,502 multiplied by 2. Is that going to give us 19,004? Well, if we check 9 times 2 is 18. Okay. And 0,502 times 2 is going to be 1,004. And if you add 18 and 1, you get 19, and you have the 0.004 after the decimal. So I'm quite happy there that I can move on. Next question is subtraction of fractions, and we have a mixed number of 1 2/5. Take away 3/4. First thing I'm going to do is I'm going to convert to improper fractions. So that's 7/5 minus 3/4. I now need to find the lowest common denominator of 5 and 4, which is 20. 5 goes into 24 times, so 4 times 7 is 28. 4 goes into 25 times, so 5 times 3 is 15, and that leaves us with 13/20. Okay? Next we have the division of a decimal by a multiple of 10, and this time it is 10. Okay? So 231,6 divided by 10. Right, the number's going to get one place smaller, so that's going to leave you with 23,16. Okay? I'm going to do question 7 just below it. So we know that when we divide fractions, okay, we can write that whole number as a number over 1. So now we have 2 fractions. We know that we must change the division sign to multiply, and that the fraction after the division sign gets inverted. So it becomes this reciprocal. So this time a quarter, and we multiply the numerators and we multiply the denominators, and we are left with an 8. Question 8 is the multiplication of fractions. Okay, so 2/3 multiplied by 3/4, and we should first have a look if we can simplify by cancelling out diagonally, and we can. 2 goes into 2 once, and 2 goes into 4 twice, and 3 goes into 3 once, and 3 goes into 3 once. Now we can multiply our numerators. 1 times 1 is 1, and 1 times 2 is 2. So your answer is a half. If you didn't cancel out diagonally, you would have first had 2 times 3 is 6, over 3 times 4 is 12, and you can see the answers are equivalent. Just remember that when I do cancel out diagonally in the question, it eliminates the need for me to simplify at the end. Okay? Your last question, question 10, is to find the percentage of an amount. Okay? And we've spoken about the different ways that you can do this. I can find 10%. I simply just need to divide by 10. So 10% of 320 is 32. If you wanted to use fractions, you know that 10% is 10 over 100 times 320 over 1. You know that 10 over 100 can be written as 1/10, so that can be simplified. All right. And now, if you wanted to multiply the numerators, it's 320 times 1, which is 320. Multiply the denominators. 10 times 1 is 10. That means 320 divided by 10, which also gives you the same answer of 32. Okay? So you guys must choose whichever method you're comfortable with. And yeah, the big thing there, guys, is to write all your thoughts down, to check your work, so that you're confident when you move on. So we're going to start looking at a little bit of algebra, and we're going to start right at the beginning. So if I gave you this problem, star plus 9 equals 17, the symbol, the star, stands for an unknown number. So we need to work out what the value of the star is. Okay? And in this instance, I'm pretty sure you guys can work out that 8 plus 9 is equal to 17. So therefore, the star is equal to 8. Okay? If we now looked at this problem, where you've got a hexagon minus an oval equals 5, the symbols, the hexagon and the oval, are both unknown numbers. Okay? So the hexagon and the oval can have many different values. Right? And these are just 2 examples. So it could be 12 minus 7 is equal to 5, but it could also be 3, 2 minus 1, 8 equals 5. Don't be too overly concerned with what numbers there are there. You could have had 25 minus 20. You could have had 30 minus 25. It's pretty much unlimited what those symbols could have stood for. The bottom line here is that the hexagon and the oval are called variables, okay, because their value can vary, all right? So that's just a little bit of terminology for you to understand, is that symbols in an equation are called variables because their value can vary. So in algebra, we use letter symbols to stand for numbers. So instead of having to draw stars and hexagons and ovals and pentagons, etc., which can be time consuming, we rather just use letters, and these letters are called unknowns or variables. Sometimes we can work out the value of the letters and sometimes we can't. For example, we can write an unknown number with 3 added onto it as n plus 3. This is called an algebraic expression. It is not called an equation. An equation is when there is an equal sign. Okay, so if you look at the word equation, it starts the same as the word equal starts. So you need an equal sign with an equation. N plus 3 is purely an expression. There is no answer to n plus 3. Let's try and write an expression. Suppose John has a packet of biscuits and he doesn't know how many biscuits it contains. He can call the number of biscuits in the full packet as B. Now he could have assigned any letter to the number of biscuits, but this time he used B, more than likely because the word biscuit starts with B, so that's where it comes from. If he opens the packet and eats 4 biscuits, he can write an expression for the number of biscuits remaining in the packet, and that expression can be B minus 4. And that is the expression for his problem. John counts the number of biscuits in the packet after he has eaten 4 of them, and there are 22. Now he can write an equation. He can write B minus 4 is equal to 22. He can therefore work out the value of the letter B, because what minus 4 is equal to 22 must be 26. So therefore B is equal to 26. And there are 26 biscuits in the full packet. When we write expressions in algebra, we don't usually use the multiplication symbol. For example, 5 multiplied by n or n multiplied by 5 is written as 5n. I would suggest and encourage you guys to always write the number before the letter. Okay? When we multiply a letter by 1, we don't write the number 1. So for example, 1 times n or n times 1 is written as n only. Okay, so a couple of important things to realize there and to remember. First of all, we do not use the multiplication sign as explained, and we do not show the number 1 as explained. When we write expressions in algebra, we don't usually use the division symbol either. Instead of using the dividing line, we use the fraction as the dividing line. So for example, n divided by 3 is written as n over 3, because we know that a fraction means the numerator divided by the denominator, so we can write it as a fraction. When we multiply a letter symbol by itself, we use index notation. And by this we mean n times n is written as n squared. Okay, so if you put a number in place there, 2 times 2 would be written as 2 squared. So for letters, n times n is equal to n squared. So here are some examples of algebraic expressions, and I'm going to put them on the screen. And for the first one, I'm going to show you that is a number n plus 7. So I'm going to put the next one on the screen. I'm going to pause for a couple seconds and give you an opportunity to try and figure out what that expression is saying, and then I'll show you the answer. 5 minus n, 5 minus a number n. 2n would be 2 lots of the number n, or 2 multiplied by n. 6 over n would be 6 divided by a number n. 4n plus 5, that would be 4 lots of a number n plus 5, or 4 multiplied by n plus 5. N cubed, that would be written as n times n times n. So a number n multiplied by itself twice. 3 multiplied by n plus 4 in brackets, or 3 n plus 4 in brackets. They both mean exactly the same thing. So remember on the previous slide we said we don't always show the multiplication sign. So here you would be correct in saying first we add n and 4, and then that answer needs to be multiplied by 3. Remember your order of operations, you always do what's inside the bracket first before you do anything else. Okay? So I would encourage you to have another look through these to make sure you understand what each expression means. Don't be overly concerned that we're using n. Okay? We could have used any letter here, but it would all mean the same thing. We could have used x plus 7. It would have just meant a number x plus 7. We could have used 5 minus p, would have meant 5 minus a number p. Okay? Just make sure you understand what each expression means. So here are a couple of examples, and I'd like you to try and come up with the answer while I'm talking through it, and then I'll give you a couple seconds before I flash the answer on the screen. But Miss Green is holding n number of cubes in her hand. Write an expression for the number of cubes in her hand if she takes 3 cubes away. You would be correct in saying n minus 3. So we assign the letter n to however many cubes there were in the beginning. We didn't know how many cubes there were, so we assign it a letter. She doubles the number of cubes she is holding, so now it becomes 2 multiplied by n, which can be written as 2n. Okay? Let's have a look at identities. So what this means is when 2 expressions are equivalent, we can link them with that sign that's on your screen. It's like an equal sign, except they're 3 identical parallel lines. So for example, x plus x plus x is the same as 3x. Okay? Remember 3x means 3 multiplied by x. So as the speech box says, x plus x plus x is identically equal to 3x. That is what those 3 lines mean. Okay? They are identical. This is called an identity. In an identity, the expressions on each side of the equation are equal for all values of the unknown. Okay, so what do we mean by that? If I had given the letter x a value of 1, we would have, on the left-hand side, we would have had 1 plus 1 plus 1, which equals 3. And on the right-hand side, we would have had 3 multiplied by 1, which is also equal to 3. So therefore, both the left-hand side and the right-hand side are identically equal. Okay? Guys, quite a lot of theory there for you to get your heads around. I encourage you to please go have a look at the online activity with accompanied memo and work through those problems I've posted on WorksheetCloud.com along with the presentation I've just spoken with you guys about. And make sure you understand these are the basics of algebra, and it's important you understand what the expressions mean and how to formulate expressions. Okay? This brings us onto our brain bender and challenger for today, which is again the game of 24. And by now I'm sure you guys know that you need to use each card. So your first card has the numbers 3, 7, 5, and 3 on it. You need to use those 4 numbers along with any of the operational signs that you wish. You don't have to use all of them, but you need to come up with the answer of 24. Remember the order of operations, okay? Divide first, then multiply, then add, then subtract, all right? And see if you can come up with the answer of 24 on each card, and also see how many different ways you can come up with the answer of 24. Grade 7s, thanks so much for joining me today. Algebra is a really important concept that you need to get your head around as early as possible, as it becomes very, very prevalent when you get to senior school. So please make sure you understand it. Go back through the presentation. Email me on grade7@worksheetcloud.com if you have any queries or if you're unsure of anything, and I can run through it again with you. But yeah, I highly encourage you to have another look at the presentation as well as having a look at the online activity with the accompanied memo, and make sure you understand what's going on. I hope you guys are all super well. Have a really cool day. Check you next time. Cheers.